Okay, so picture this. You're sitting in a movie theater watching some near-future cyberpunk thriller.
Mm-hmm.
And the antagonist isn't, some hacker in a hoodie furiously typing green code in a dark basement.
Right, the classic trope.
Exactly. Instead, the bad guy is sitting in a nice office chair, leans back, and just tells the computer, write me a virus that can steal $1 million and make it undetectable. And the computer just does it.
Yeah, it just spits out the code. It sounds like a movie that would get absolutely roasted online for being unrealistic.
It really does. But unfortunately, we're not talking about fiction today. We're talking about the reality of, well, right now, January 2026.
And that's the scary part.
It is. We are diving into a report that just hit the wire on January 24th, reporting by Bill Toulis based on some, incredibly deep forensic research from Checkpoint.
And it is a wild one. We're looking at a notorious hacker group that is now using artificial intelligence to basically ghostwrite their malware.
We've seen AI used for the soft side of hacking for a while, right? Like generating phishing emails, fixing grammar.
Oh, absolutely. But having AI actually structure, write, and even document the malicious code itself, that's the threshold. That is the big shift we need to talk about.
So the mission for this deep dive is to unpack this latest campaign by a group known as Konni.
Right.
If you're a blockchain engineer, or just someone who hangs out on Discord servers for crypto projects, you are the target here.
Mm-hmm.
But even if you aren't technical, this story is really about how the barrier to entry for high-level cybercrime is just crumbling.
It's crumbling because of the very same tools that legitimate developers are using to be more productive. It's a double-edged sword.
So we're going to look at the who, the how, and specifically that bizarre AI twist that makes this whole thing so fascinating.
Let's do it.
Okay, let's start with the actors. Who exactly is Konni? Well, because in the threat intel world, names can get, confusing fast.
They certainly can. Konni isn't a new player. They're a North Korean threat actor, and they've been active since at least 2014.
Okay, so they've been around.
They've been around, and depending on which cybersecurity firm you listen to, you might hear them called Opal Sleet or...
Oh, right, TA406. I've seen that one.
Exactly. It's like a band with too many rebrands.
The artist formerly known as Konni.
A bit, yes. But the consensus is that they are deeply tied to the North Korean state. They're associated with major activity clusters like APT-37 and Kimsuki.
So historically, they've been going after political targets, espionage, state secrets, that sort of spy novel stuff.
Precisely. Usually they'd be targeting government organizations, diplomatic entities, mostly in South Korea, Russia, Ukraine, and Europe.
But this is different.
This is a distinct pivot. What the Checkpoint researchers found in this latest campaign, the one we're talking about now, is they aren't just looking for intel. They're looking for liquidity. Cold, hard cryptocurrency. This campaign is zeroing in on the blockchain sector. And the geography has shifted to match the malware samples. They were submitted from Japan, Australia, and India.
So a heavy focus on the Asia-Pacific region. And the end game isn't just disruption.
No. This is a heist. By targeting blockchain engineers, they are trying to compromise development environments. If you can get onto a developer's computer, you get,
well,
everything. Keys to the kingdom. Literally. Infrastructure access, API credentials, and most importantly, the wallet keys.
It's way easier to steal the bank manager's keys than to crack the vault, right?
That's the logic. It's a high-stakes heist, all digital.
Okay, so we've got the who and the what. Let's get into the how, because this is where the sophistication really shows up. It starts, surprisingly, on Discord.
It does, which makes perfect sense if you know the culture. Discord isn't just for gamers anymore. It's the de facto office for Web3. It's where all the developers hang out.
So you're a developer on a Discord server. You get a direct message. Maybe it looks like a job offer, a collab request, something with a link.
Right. The link delivers a ZIP archive, and inside that ZIP you have two things. A PDF, which is just the lore, and a malicious LNK file.
Let's pause on LNK for a second. That's just a shortcut file, isn't it? Like the little icon on your desktop that opens Chrome.
Exactly. It stands for link. But here's the trick. An LNK file doesn't just have to point to a program. It can contain commands.
So it looks innocent, like projectproposal.lnk, but when you double-click it, it's not just opening a file. It's running a script in the background.
That is exactly what happens. The user clicks it, and that shortcut executes a hidden PowerShell loader. But, and this is the clever part, to keep the victim from getting suspicious, it also opens a decoy document.
The classic Trojan horse. Here, look at this shiny thing while I rob your house.
And the content of that decoy document is, well, it's deeply ironic.
I saw this in the notes. It's almost funny.
So The decoy is a normal docx file, but the text inside it pretends to be a legitimate security guide about how hackers try to compromise development environments to steal crypto.
Wait, so the virus is literally warning you about itself.
Yes, essentially. It uses the exact terminology of the attack to look like a legitimate task. It's telling you, hey, watch out for people trying to steal your API keys while it is actively stealing your API keys in the background.
That is incredibly bold. It's like psychological gaslighting.
It creates a false sense of security. You think, oh, good, I'm learning how to stay safe. You're not thinking, this document is the threat.
Okay, so while I'm reading this ironic safety manual, what is happening under the hood?
The LNK file is busy. It extracts a CA archive. Think of it like a system ZIP file. And inside that, you have a whole toolkit, a PowerShell backdoor, 2 batch files, and a UAC bypass executable.
UAC, that's the user account control, right? The little pop-up that asks, are you sure you want to let this program make changes?
Right. That pop-up is the last line of defense for a lot of people. Konni has a tool specifically to get around that so the malware can run with higher privileges without you ever knowing.
Okay, so the infection is in. But now we get to the part of the story that makes this whole thing so unique. The researchers at Checkpoint open up that PowerShell backdoor and they notice something's off.
Off is a good word. See, malware written by humans is usually messy. It's efficient, but it's often spaghetti code. Variable names are just random letters, and they never, ever have comments explaining what the code does. Why would you document your crime?
You don't leave a diary at the crime scene. But this was different.
It was incredibly clean, modular, and weirdly enough, it had clear, structured documentation at the top of the script explaining the functions.
It's like finding a burglar who left a neatly typed itinerary of which rooms they were going to rob.
Exactly. And the structure, the way it did things like arithmetic-based string encoding, it just screamed, machine-generated. It was too polite, too organized.
And they found more than just a hunch. They found a smoking gun, right? A comment left in the code.
This is the detail that proves it. Buried in the script was this comment. Hashtag your permanent project, UUID.
Hashtag your permanent project, UUID. Why is that the smoking gun?
Because that is exactly how a large language model like ChatGPT talks to a user. If you ask an AI to write you a script, it doesn't know your specific server ID, so it puts in placeholders.
It says, insert your API key here, or put your project ID here.
Precisely. So the hacker went to the AI, said, write me a backdoor. The AI wrote it and said, here you go, just fill in this blank with your ID.
And the hacker just forgot to delete the instruction.
It appears that's exactly what happened. It is a pure copy-paste error. They didn't clean up the tutorial notes left by the AI.
That is just incredible. It's high-tech cyber warfare backed by a nation state, and it's exposed by what? Pure laziness.
It tells us something really important about the operator. We think of these advanced, persistent threats as geniuses, but this shows they're relying on these tools to do the heavy lifting. Checkpoint said the phrasing is highly characteristic of LLM-generated code.
But I want to be careful here. We're laughing at the error, but the code itself, it worked, right? It wasn't broken.
Oh, that's the scary part. The AI wrote functional, sophisticated malware. It obfuscated strings, it used invoke expression, it did a great job. The human was the weak link.
Okay, so this thing is dangerous. Let's talk about how it stays hidden. How does this avoid detection once it's inside?
It uses a few layers of camouflage. First is persistence. It needs to run every time you turn on your computer. It does this by creating a scheduled task.
And I'm guessing it doesn't call the task Konni malware.
No, of course not. It masquerades as a OneDrive startup task.
Ooh, that's smart. Everybody have OneDrive. If I look at my task manager, I'll see a dozen things that say OneDrive. I'm not going to blink.
It just blends in. And this task runs hourly. But it doesn't just run a file. It reads an XOR-encrypted PowerShell script that's hidden on the disk.
Let's break that down. XOR encryption.
It's a basic but really effective way to scramble data. To an antivirus scanner looking at the file on the hard drive, it just looks like gibberish, random noise.
So the antivirus scans the drive, sees random noise, and just ignores it.
Right. But when the scheduled task runs, it takes that noise, applies a key, and decrypts it back into malicious code only in the computer's memory.
So this is what they call fileless malware.
Or living off the land.
Yeah.
It's using tools already on your computer PowerShell task scheduler to run code that only exists in RAM. It never touches the floor, so to speak.
A ghost in the machine, and it cleans up after itself.
Yes. Those initial batch files from the ZIP, they delete themselves after the backdoor is set up, so the evidence of how you got infected just vanishes.
Now, you said the AI included environment checks. Does the code know if it's being watched by a researcher?
It does. Before it runs fully, it checks hardware specs, software installed, user activity.
It's looking for a sandbox, right? A virtual environment where researchers detonate viruses.
Exactly. Sandboxes look different. They might have generic hardware names, weird screen resolutions, or, and this is a big one, no mouse movement. If the malware doesn't see a mouse moving, it assumes it's in a lab.
And it just plays dead.
It goes dormant, it won't run its malicious payload, it protects its secrets so the researcher can't see what it's capable of.
Deceptively clever. Okay, so let's say it passes the checks. It's running in memory, disguised as OneDrive. What's next?
It calls home, it connects to the command and control server, the C2.
How does it do that without tripping network alarms?
It uses a couple of tricks. First, it generates a unique ID so the hackers can track each victim. But critically, it polls the server at randomized intervals.
Why randomized?
Because security software looks for patterns. A signal every 60 seconds is a heartbeat. That's a bot. But if it checks in at 4 minutes, then 12, then 7, it looks more like normal human web traffic. It's called jitter.
It breaks the rhythm so the algorithm can't catch the beat.
Right, and when it connects, it's looking for new instructions. If the server sends back new PowerShell code, it runs it asynchronously.
Meaning in the background so it doesn't freeze my screen?
Exactly. You could be on a Zoom call, and the malware is executing commands in the background without causing any lag. You'd never notice the performance hiccups that might tip you off.
Terrifyingly efficient. Now, how do the researchers actually know this is Konni? Is it just a guess?
Attribution is always a puzzle, but here, the fingerprints are all over the launcher format.
Trusted format.
The specific way the LNK file launches PowerShell. It matches historical methods used by Konni almost perfectly. They also found big overlaps in the file names they used.
So they're recycling their old playbook.
In a way, yes. They're using AI to write the content of the code, but their operational habits, the structure of the attack, how they package the files, it's the same. It's the same behavior, just with a new AI-enhanced author.
So let's zoom out. What's the big takeaway here? Why does this matter beyond just, update your antivirus?
The big takeaway is the lowering of the bar. We used to think of state-sponsored malware as something that required teams of elite coders working for months. Now, a threat actor can use the same LLM that you use to write an email to generate sophisticated, evasive malware. It speeds up their development cycle drastically.
If a security company blocks one version, they don't have to spend a week rewriting it.
They can just ask the AI, rewrite this code to avoid detection by X, and have a new version in seconds.
That's a daunting thought. It's an arms race where one side just got a machine gun that never jams, except when they forget to delete the user manual.
For now. But they will learn. They will get better at their prompts. They'll automate the cleanup.
So if you're in the blockchain space, this is your wake-up call, that PDF on Discord, maybe just don't click it.
Basic hygiene is still your best defense. Verify the sender. Don't open unexpected attachments. And look, if a document tells you to be careful about hackers, maybe take its advice literally and scan your computer.
We've covered the who, the how, and the weird AI why of this campaign. Classic new tech meets old school espionage.
It is, and it's a reminder that as AI gets integrated into software development, it's also being integrated into malware development. The tools are neutral. The intent is what matters.
We're going to wrap it up there, but before we go, I want to leave you with one final thought.
What's that?
We laughed about the copy-paste error, that UUID comment, but that was a human error. The AI did its job perfectly. The code worked, the encryption worked, the evasion worked. The human failed to cover the tracks.
That's a chilling point.
So here's the question. As these threat actors get better at prompting and better at cleaning up the code, will we lose the ability to distinguish between human-written and machine-written threats? And if the AI writes cleaner, better, and more efficient code than the humans ever did, are we approaching a point where the malware is actually smarter than the people trying to stop it?
That's the million-dollar question for every defender out there. We might be moving from cat and mouse to machine versus machine.
Something to think about. Thanks for listening to The Deep Dive. Stay safe out there.